Okay, now we'll go to the applications of differentiation. We just cover two of it: tangent line equation and also displacement, velocity, and acceleration. So first, we'll take a look at the tangent line equation. Okay, so we consider the function y equals to fx. Okay, with point x1, y1 lying on the function graph. So tangent line to the function of at x1 and y1 is the straight line that touches at the point. Okay, normal line is the line that is perpendicular to the tangent line. Okay, if I may draw clearly, so we have x-axis and y-axis. So if there is a curve, so for example we have x1, y1 here. So a tangent line is a straight line that goes through this point on the function fx. This is y equals to fx. So this is called tangent line. And then we can also find the equations of a line perpendicular to the tangent line, which is called normal line. Okay, that's it. So we'll use concept of differentiation to find the tangent line and normal line of the curve. Okay, first the dy dx. When we perform dy dx of a function or of a curve, actually we'll get the value of the gradient. Okay, so if we're given a point, we can substitute the point in the dy dx function, so we get the value of the gradient. So if we have the gradient, we can get it to find the tangent line equation, which is equal to mx, y equals to mx plus c, or this one. And the same thing, if we have the gradient, we can find the normal line equation. Okay, using these two equations. So first, we need to differentiate the functions to find the m, or the gradient, and then we'll substitute the gradient in the standard form, the standard equation of tangent line and normal line. Okay, let us take a look at the example. So find the slope of the curve at a given point. So slope here means gradient. It's the same thing. So for A, so again, to get gradient is the dy dx. Okay, so for A, dy dx equals to 2x minus 2. So this is the gradient function. So at x equals to 3, so the m, or dy dx, is equals to 2. We just substitute the point there because we want to know the gradient at this point, or this x equals to 3. So your m will be 6 minus 2, which is 4. That's it for A. Okay, for B, the same thing. Our objective is to find the dy dx, meaning we want to differentiate. So if we see this function is actually explicit function. Okay, so we are going to solve it implicitly. It's implicit function, sorry. So we are going to differentiate implicitly. So you will get 2y. Okay, dy dx. Remember, implicit differentiation, every time we differentiate y, we have to multiply by dy dx. Okay, and then plus 2x equals to 4y cubed dy dx minus 2. Okay, and then we move dy dx on the left, term with no dy dx on the right. So 2y dy dx minus 4y power 3 dy dx is equals to negative 2 minus 2x. Then we factor out dy dx, we get 2y minus 4y power 3 equals to negative 2 minus 2x. Sorry, not yet. So dy over dx is equals to negative 2 minus 2x, divided by 2y minus 4y power 3. So it's given a point. So at point 2, negative 2, 1. So we substitute x equals to negative 1, y equals to 1. So your m is equals to, since m is dy dx, so m equals to negative 2 times negative 2 divided by 2 times 1 minus 4 times 1 power 3. So the answer will be negative 2 plus 4 divided by negative 2, which is equals to negative 1. So that's the answer, the slope of the given curves. Okay, so we look at the next example, number 2. So this one, find the lines that are tangent and normal to the curve at the given point. So meaning we want tangent line and normal line. Okay, so in order to get the tangent line and normal line, we need to find the slope or the gradient or the dy dx first. So m equals to dy dx. So for a, dy over dx is equals to 2x plus 3 is equals to 2x. So m at that point is equals to 2 times 2 equals to 4. So to get the tangent line, we have the equation y minus y1 is equals to m times x minus x1. So what is your y1 here? So you need to substitute in this curve to get the value of y. So y is equals to 2 squared plus 3. So when x equals to 2, y must be equals to 7. So the point here is 2, 7. So here x1, y1. So y minus 7 is equals to m is equals to 4. 4x minus 2. So y minus 7, we have to write y equals to mx plus e. For x minus 8, so y is equals to 4x minus 1. So this is the equation for tangent. For the first one, tangent. How about the we call it normal? So for normal, the equation for normal is y minus y1 is equals to negative 1 over m of x minus x1. Am I right? So you have the value of y1, m, and x1, so you just substitute it. So y minus 7 is equals to negative 1 over 4 times x minus 2. So the answer will be y equals to negative x over 4 plus 1 over 2 plus 7. So the final answer will be y is equals to negative 1 over 4x plus 15 over 2. So this is the normal line. Okay, so next for b. For b is implicit again, so we need to differentiate implicitly. So you get x dy dx plus y minus 2y dy dx equals to 0. Okay, and then we collect x dy over dx minus 2y dy over dx is equals to negative 2x minus y. So dy over dx x minus 2y is equals to negative 2x minus y. So dy over dx is equals to negative 2x minus y divided by x minus 2y. So this is your dy dx. So you need to find the m. So at 0.23, so the m will be negative 2 times 2 minus 3 divided by 2 minus 2 times 3. So your m is equals to 7 over 4. Okay, so to get your tangent will be y minus 3 equals to 7 over 4 times x minus 2. So your y is equals to 7 over 4x minus 1 over 2. For the normal, y minus 3 is equals to negative 4 over 7 x minus 2. Okay, we just follow this formula. So the answer will be negative 4 over 7x plus 29 over 7. Okay, that's it. Okay, now we proceed with the next applications of differentiation, which is called displacement, velocity, and acceleration. So if S is the displacement of a moving object from a fixed plane and t is time, then the velocity v is given is this one. So v is the rate of change of S, the displacement, or ds over dt. So we differentiate S, we get the velocity. And if we differentiate A, acceleration, we will get differentiate V, we will get A. Okay, so S V A. Okay, to go to this, we differentiate. Okay, so this is ds over dt, this is dv over dt, or ds d square s over dt square, meaning we differentiate s 2 times. Okay, if you want to go back, so if you want to get v from a, so we need to integrate. Okay, same thing here, we need to integrate. So that's it, the connection between displacement, velocity, and acceleration. If you have displacement s, you differentiate one time, you will get v, the velocity. Differentiate v, you will get a. Okay, that's it. So now let's take a look at the example. So a particle is moving in a straight line and its distance s in meters from a fixed point in the line after t seconds is given by the equation s. Find the velocity and acceleration of particle after 3 seconds. So it's given s is equals to 12t minus 15t squared plus 4t power 3. So to get v, for function v is just ds dt, so differentiate one time, so you get 12 minus 30, so this is 15, t plus 12t squared. Okay, To get A, differentiate t ds dt one more time, or dv over dt. So you will get, differentiate this one, the negative 30 plus 24t. So it's given at time 3 second, at t equals to 3 lah. So v is equals to 12 minus 30 times 3 plus 12 times 3 squared. So what's the answer? So A is equals to negative 30 plus 24 times 3. So what's the answer? So here is 30. The unit is meter per second. How about this one? So the acceleration is 42 meter per second. So that's it. It's very simple. So next example. A particle is moving in a straight line and its distance s in meters from a fixed point in the line at 50 seconds given by the equation s. So find the initial velocity of the particle. So initial velocity means tv when t equals to 0. Okay. B, find the acceleration of the particle after 3 seconds. So it's t equals to 3. So let us do for A. So S is given equals to negative t minus 2t power 3 plus 3t power 4. Okay, so the V is ds over dt. We differentiate s respect to t, we get negative 1 minus 6t squared plus 12t cubed. Okay, so the initial velocity means t equals to 0, so v must be equals to negative 1 minus 6 times 0 plus 12 times 0. So the answer for v is equals to, so since this one is 0, this one is 0, negative 1. So this is the initial velocity. Okay, for B, we need to find the A. So A we obtain from V. So A is equals to dV over dt. So you will get a negative 12t plus 36t squared. Okay, so now t equals to 3, so A must be equals to, so we substitute t equals to 3. So the answer for this is 288 meter per second square. So just now the unit is meter per second. So that's it, the connection between velocity and acceleration and also displacement.